Hi friends, how are you all? So, in this lecture, we will be dealing with an important topic in set theory, which is the Venn diagram. Before I go into the topic of Venn diagram, let us first discuss what is the cardinality of a set. Okay, first concept is cardinality. See, let us take the set. Set of all natural numbers less than or equal to 5. And what are the elements here? 1, 2, 3, 4 and 5. But here we are writing all the elements. Sometimes our main concern will not be the elements, but the number of elements. Here you see 1, 2, 3, 4, 5. There are only 5 elements. Right, 5 elements. Now, based on the number of elements, we can group sets into two. That is finite and infinite. If the number of elements is measurable as a natural number, because we don't, no set can have negative numbers of elements, or no set can have fractional number of elements. They can only have natural number of elements. Might be 0 will be included as well in the null set. Okay, based on the number of elements, we can group sets into two, finite, and if we cannot find the number of elements, it is too much, it is too large, then it is infinity. It goes on. Let's say the set of all odd numbers. When you say the set of all odd numbers, it will go 1, 3, 5, 7, 9, 11, 13. It will go on. So the set is infinite, in fact. Okay. So this is about finite and infinite set. But the number of elements of a set is called the cardinality of a set. Okay. Cardinality of a set is the number of elements in it. That is denoted by, let's say this set is A. If A is this set, then NA is equal to 5. That is, number of elements in A is equal to 5. Now consider the two sets. Right. We studied the operation of union, intersection and such things, right? So, if we want to find the number of elements of N, A union B, let A and B be any set. If we want to find the number of elements of A union B, how do we do? Let's say A is 1, 2, 3, 4, 5 and B is 2, 4, 6. So, A in union B will be 1, 2, 3, 4, 5, 6. Right. It will have 6 elements. But when you add the number of elements of A and B, you will get 5 plus 3, 8. And what is the 2? The difference between 8 and the number of elements, let's say, here we get number in A union B is equal to 8. Now, NA plus NB is equal to 8, right? Now, number of elements is equal to 6, NA plus NB is equal to 8. The difference is 2. And what is this 2? The number of elements in A intersection B. So, NA union B is equal to NA plus NB minus NA intersection B. This is the first formula. Similarly, there are formulas for everything. If N A union B union C is equal to NA plus NB plus NC minus NA intersection B minus NB intersection C minus NA intersection C plus NA intersection B intersection C. This is the formula for 3 sets. But taking all these formulas, it is okay for 3 sets, but if there is more, then it will be somewhat difficult. Is there any method by which we can find the number of elements simply, like a graphical or diagrammatic method? Yes, there is one method. That method by which we find the cardinality of union or something is called Venn diagram. Okay, now we are going to the main topic, Venn diagram. Venn diagram. It is actually, let's say, it is a big box like this. Here, what is this box? It represents the box represents the universal set, and universal set here we will write whatever be the elements of universal set. Let us say the universal set has 50 elements. Now let us consider three sets. A. This is the set A, and let us say the number of elements in A is 12. 1, 2, 12. Number of elements in the set A is 12. Let us say the number of elements in the set B. This is how we represent. The universal set will be a big square or rectangle. All other things will be ovals or circles. Your preference. Okay, why am I writing it here? The number of elements in A, I am writing it here. I will tell you the reason. Let us say the number of elements in B is 5. And let us say the number of elements in the set C is 9. Let's see, 9. Okay. This is how we write. A has 12 elements, B has 5 elements, C has 9 elements. Now, what do we want to find? What we want to find is the number of sets in A, so the elements in A union B union C. Okay. Number of elements in A union B union C. So, let us say A intersection B has, before that, this point is A intersection B intersection C. First, we will denote the element, whatever be the given number of elements in A intersection B intersection C, we will write it here. Let us say it is 3 elements. Okay, it is 3. A intersection B intersection C is 3. And let us say A intersection B is 5. Now, A intersection B is 4. So, what will be this? Let me draw this even more better, because you won't be able to see this A intersection B intersection C. This is A and it has 12 elements, and this is B and it has, let's say, 6 elements instead of 5, and let us say C and it has 9 elements. Okay. First, let us take A intersection B intersection C. Let us take it has 3 elements. And suppose A intersection B has 4 elements. A intersection B will include A intersection B intersection C, right? If A and B have a common element and A, B and C have common elements, definitely the common elements of A, B and C will be included in the common elements of A and B. So, this is the part here. So, if A intersection B is 4, this will naturally be 1. Right. Naturally be 1. This will naturally be 1. And let us say A intersection C is 5. This will be 2 here. This is how you will have to find. A intersection C is 2. Then B intersection C, let us take it as 5. This will also be equal to 2. Now, we are going to find the number of elements that are present only in A, only in B, only in C. So, what will be this? Here it is 2, 1 and 3. 2 plus 1 plus 3, 6. So, 12 minus 6, 6 elements are there which are present only in A. Similarly, if we find 2, 1, wait, 1 plus 3, 4, just 1. Okay. 1 plus 3 plus 4, 5. There is one element that is present only in B. Here, we are changing that B intersection C is only 4. Now, consider C. 2 plus 3 plus 1 is 6. So, 9 minus 6, 3 elements are those which are present only in C. Now, when you add all these, don't add the outer, add the interiors only. You will get 3, 4, 6, 9, 10, 11 and 17. Now, if you use the formula, also you will be getting 17 elements in A union B union C. How come? A plus NA is 12 plus NB is 6, 12 plus 6 plus NC is 9, right? Minus NA intersection B means minus 4, minus NB intersection C minus 4, minus NC intersection A minus 5, plus 3. When you see 12 plus 6, 8, 12 plus 6, 18, 27, minus 8, 19, minus 5, minus 19 minus 5, 14, plus 3, 17, same answer. So instead of using the formula, we can use this method. How it is applicable for how many ever sets you use. So this will be with this important lecture in Venn diagram, which have many applications in set theory and many branches of mathematics and other logical reasoning as well. So we will be meeting again in the next lecture. So till then, stay safe. Thank you.